Hey, welcome back. Good to see you all again. And thanks for joining the channel. Glad you could make it. Glad I could make it too, because I finally got my PC back up and running and I can start posting videos again. So I have to get back into the groove of doing that. I know it's summertime. It's hard to get on the bench when it's so nice outside. But anyways, you guys voted on this receiver. It was very, very close. I totaled up the votes and I had to do it a couple times because it was so close. The other two receivers, the 210 and the SR600, they're older, but they were actually tied, and then this one beat the other two by one vote. So here we are. We're going to do this one today, and let's get at it. This is a 75 plus from Harman Kardon. It is a quadraphonic, or maybe yeah, it is a quadraphonic. I guess you could call it quadraphonic. It says it's a multi-channel receiver, but it's quadraphonic. It's got, let's see here. It has two sets of speakers, main and remote, and a switch for external Dolby. I don't know if that's 2-channel or 4-channel. We got tape monitor 1, loudness or contour, FM muting. Can't even read this. Low cut, high cut. And then it has our input selector, phono, stereo FM, mono FM, discrete FM, auxiliary, because I can feed in 4 channels on the back from a quadraphonic decoder for FM. And then it has discrete phono or auxiliary on the back. There's another 4 inputs there. And then it's got AM, bass, treble, mode switch. It's kind of a confusing thing here too. It's got mono, stereo, SQ matrix 1, SQ matrix 2, enhanced stereo, and it's got 4-channel discrete. Okay, and then a volume control, tuning knob, and a balance control, which is just a joystick. But this is broken. It's not working. It's not connected to anything inside there, so we're gonna have to deal with that. I have been listening to it for a few weeks. Look at that. It's got a price tag on it from November of 2020. So that's almost 2 years ago. I bought this on eBay, yeah, almost 2 years ago, and it's been sitting here. I did hook it up and use it last year on my desk, and I was curious on how it sounded, and it sounded pretty good. It does have problems though. It has heavy DC on the left channel, and I think that's because of bad caps in the preamp section. You get some loud thumps when you hit the some of these buttons, and when you let it sit idle for a number of weeks and you come and turn it on, it has a really loud thump on the left side. And I think it's, like I said, bad caps. So we'll address that. FM. We don't have any antennas hooked up. It doesn't seem to be doing anything. Let me try an antenna. This thing weighs a ton. It is dual powered, so it has 2 transformers, 2 power supplies, 4 amplifiers. Oh man. Okay, let's try and hook up a... You know what? Let's look at the back panel first. Let's look at the back panel first and then we'll hook it up. Alright, so we've got a bar antenna inputs for AM, FM. We have a magnetic phono input, front, left, and right. And then we have a discrete phono or auxiliary input, which is 4 channels here. We have discrete FM auxiliary input, it's 4 channels. Tape monitor 1 is 4 channels. Output for tape 1 is 4 channels. Output for tape 2 is 4 channels. And then the Dolby and tape monitor 2. Okay, so they're using that, the 4 channels. They're using that as a an extra tape loop. Muting adjustment, stereo threshold, that's for the tuner. And then we have an output for undecoded 4-channel FM out. So if you want to decode the four channel signal out of this FM, you get an external decoder, hook it up here, and then feed it back in. 4 fuses, 1 for each amplifier. These are speaker fuses. All the amplifiers are working. I've tested front and back, and they're all good. Stereo 4-channel switch. I don't know exactly what that does. Main power fuse and 1 courtesy outlet. And then we have our 8 speaker outputs. Yeah, there's 8 here because there's remotes for the front, and there's remotes for the back. So you can actually connect 8 speakers to this. Okay, let me hook up speakers and a antenna, and we'll try out the FM AM. Okay, we're back again, all hooked up. So let's turn this on. Turn off these big lights. Maybe you get a better look at what's going on here. Okay. We've got nothing. Okay. I'm hooked up to the wrong. So you can hear there's a little bit of DC when you click the speakers on. With use, that goes away. And I think that's just weak leaking capacitors. But anyways, it does work. Picking up stereo.
$9 down. Visit shoptoyota.ca.
Picking up stereo on most of the stations.
Out of hunting us.
Not all of them.
De notre part, hein?
Okay, let's try the phono. Let's listen to the background noise. It's quite noisy. Volume's a little scratchy. Treble's clean. Bass is clean. Got some hum there. So that's with no input. Okay, let's try discrete. That's a dead input. AM.
Basically, you know what, if you could
for extending themselves.
It's doing really well.
and if the Texans did in fact, you know, end so
yeah. 2 AM tuners working excellent.
Since the beginning of the year. Or hospital to unless you were.
Okay, so I have a good idea what we need to do. We have a burned out lamp, and all the other lamps are working, it seems. We have 1 is for mono, 2 is for stereo, 4 and 4 is the matrix, and then we have 2 and 4 channel for the discrete, enhanced and discrete. I did check all 4 amplifiers, and I did run off the front 2 and the rear 2, and the front 2 sounds a little rough. Let me see if we can get, can't really get any music here to show you. Let me try AM. Okay, so that's mono, stereo. That is SQ Matrix 1. And what it does is I get a loud, sounds like there's a loud center speaker right in front of me. That's what it does, kind of. mono. Let's try that again. Mono. And it has kind of a stereo effect, even though I'm on AM and it's a mono signal. It has kind of a stereo effect, whereas it sounds like there's a center speaker, but it also sounds like there's a right and a left.
Call 780-249-2010.
There's no difference between the 1 and 2 SQ matrix.
Festival the World Music Week with Harley Park and Grounds.
Okay, now we're on discrete. And this is enhanced stereo.
3 night tickets for $50.
So it's basically doing the same thing as the SQ matrix. So I think there's problems within the SQ matrix and the enhanced stereo module on this thing. I think there's bad caps in here. I got imbalance from the side speakers. We have this that we need to fix. We don't know if that is not working. And basically everything else is just cleaning switches and replace one lamp, and then we have to fix that. So okay, I have a good idea what we need to do here. All right, let's have our first peek inside. Oh, what is that? Looks like something burnt. Smoke. Can you see that? Where does that coincide with? That is... Where is that? That is right here on this amplifier. Yeah, there's some burnt wiring here. Okay. Let's have a look. Dual power supply. Let me unplug this before I poke my finger into some wrong place. Dual powered, so it's got 2 transformers, 2 power supplies, sets of capacitors, and then we have 4 amplifiers. There's a little power supply board down here in the left corner. It's got some regulators and some caps. We have our tuner board on the back right corner. Takes up quite a bit of space, AM, FM. And then here we have, these are either the preamplifiers or the phono amplifiers. I think this back one here is phono amplifier, and this one is maybe a preamp or a line amplifier. Everything looks original. Everything looks untouched. I don't see anything going on with the wiring harnesses. Everything looks wrapped and tied. So it doesn't look like somebody's been into here before, but I do know somebody's had the cover off. This concerns me here, this what was going on. Even though I did listen to all 4 amplifiers, and all 4 of them did work, so maybe we have an intermittent problem in that one back there. 6800 microfarad capacitors, 6800 at 35 volts. It's not a power beast, but it is a nice little unit. Okay. And then we have PCB boards stuffed under here that are difficult to get to. Let me show you here. We have the dial lamps here in this assembly, and there's a meter lamp here. Our dial string tuning, and then underneath we have all our switching, 4 channels of switching and tone controls. And yeah, it's going to be very busy underneath here, so it's going to be difficult to service. Let's pull off the bottom and have a look at that too. Alright, so I got the screws out now, and this is a normal amount of dust, I guess. Somebody's been in here before, because I could tell the screws were all mismatched, different types of heads. So somebody's been poking around in here and had the bottom off the top, and I don't know what they were doing, but we'll find out. Yeah, look at the Look at the mass of wires here. What a nightmare. Okay, and it looks like these two boards are sitting in card connectors, so that's kind of cool. You can just pull the card out and service it. Here's the 4 power amplifiers. Here's the wires going for them. It looks like I would just have to desolder these wires and then I could just take the amplifier out. There's a little board here with some little tiny transistors on it. I don't know what this is all about. I don't know what that is. Rectifiers. 2 sets of rectifiers for the 2 transformers. Filter caps. There's a switch here. Very nicely built. It's very nice construction to these. They did put a lot of effort into making a good product, and it's not often you see that. Okay, another thing I noticed. Okay, so one thing I found is this thing fell out from inside. It's a steel rod with a brass end on it, and I think that came from here. I think that goes on the back side here, and this is what controls the different. You can't see, there's no light. See, there's our potentiometers swing for left and right, and then this would swing for front and rear, and this would sit in the middle of it. And there's a couple of little washers here. You can see these little washers. You probably can't see them, they're pretty tiny. I think this rod sits inside the washer and it kind of makes a connection there, physical connection. You can see that little washer. This appears broken here. This is plastic. A little bit of, it looks like threaded plastic. And looks like it came right out of that ball. There's a ball in there. So we either have to reattach that or manufacture a little part so that it works again. So what else do I have planned other than fixing those few other things? I'm probably going to give this a full recap. These capacitors are, see date codes of 1973. 1973. They are smoking old. So I'm going to probably give this thing a full recap. I know it doesn't, I did listen to it and it sounds good. And a lot of people say, well, if it's good, leave it alone. But you also have to remember these caps are, if they're approaching 50 years old now, they are going to fail. They will, not a matter of will they fail, it's just a matter of when they fail. So let's address all that by replacing them with all brand new caps, and then this thing can live on for another 50 years. Just going to pull these little things out. I'm curious as to what's going on with these boards. Come on. So many cables in the way. I'll get the screw later. Okay. Here's one card. It looks like it has 4 channels of something on here. And then he's got these Sanyo LD 3130s. I guess these are like an early preamplifier chip. This might be the phono stages. I'm really not sure. Somebody's been working on this. This is not factory. It can't be. Would they hand solder all this? I guess they would. They wouldn't have wave soldering back in '73, would they? There's a joint here that looks iffy. Let's pull the other one out. Yeah, I just know some of these caps are going to be bad. I can just feel it in my bones right now. Other than that, everything looks good. Dirty, but it looks good. $50 volts, 22 microfarad, 50 volts. Interesting. got a 5 gain tuning capacitor. The smaller plates are for FM. The big plates are for AM. There's typically two sets for the AM. One's for the oscillator, one's for the antenna tuning. And then you have 3 plates for the FM. Gold-plated connectors. Alright, so I think what I'm going to do, there's no troubleshooting to do on this. Everything seems to be working. I think I'm just going to start recapping and go through, and we'll get this thing with all brand new caps. Some of these transistors though are kind of suspect too. These are I don't know if those are prone to failure. What do we have here? 6930 693G. 693G. I wonder if that's a 2SC part number. I guess I should get the manual out and have a look. Before I tie into this thing and start ripping it apart and replacing capacitors and doing this and doing that, I want to take some baseline results here. I want to see how much power this thing consumes. Now I know it's going to be kind of irrelevant because the bias on these 4 amplifiers is probably not set properly. So I'm going to do 2 things here. We're going to test it now, and I'm just going to let it warm up. I want to get a baseline on how much power this thing uses with and without the power amplifiers, because there's a lot of capacitors in this thing. I want to replace all the capacitors, and I want to see if that makes any difference in its power consumption. If you have leaking capacitors, my thought is you're going to lose a little bit of power at each one, right? Like a few milliwatts or a few hundred milliwatts, depending how bad it's leaking. So put brand new ones in. We'll see if that makes a difference. This thing does have problems with capacitors. Just looking at it, I pulled one out yesterday and tested it, and it's high in value and high in ESR, which tells me that they're leaking and they're failing. But they're still working. There is some bad ones in here that are causing problems. Another thing I want to check is DC offset on the amplifiers, because I don't believe there is an adjustment for it. Let's see if we can get a baseline on those two. So on the mains, let's go to mains. Left channel to 0. This one here is 0. Do I trust this multimeter? 0, 0. They're all 0. Let's go a little. Maybe this multimeter is no good. Maybe that's why I found it in the scrap bin. Okay, let's try another one. Okay. So I got around 1 millivolt there. About 60 millivolts there. 20 millivolts there. And last one is really unstable. It's all over the place. But it's between 0 and 20. Now just looking at this thing, since I turned it around, I can see already somebody's replaced the output transistors on this back amplifier. This is the one where we saw the smoke stain from the lid. They put new transistors, MJ15 and 015s. So this amplifier bloated up sometime in the past. All these other ones are running cool. Power consumption's still climbing. I'm going to let that go for about half an hour. I'm going to see how this settles out at, so I get a good baseline. And then I'm going to disconnect all 4 amplifiers, and I'm going to take another reading, and then we'll find out how much power the rest of the circuits are using up. Going through the schematic, we have a power supply here that supplies supply B5 is 30 volts, and that supplies all of the as far as I can see, it supplies all of the tone amplifiers, the phono amplifier, the phase inverter board, and I don't know what board this is, the SQ board, and then there's also a B6 supply, which is 12 volts, which is regulated down once more, and I think that supplies the tuner, but I haven't been able to find the power feed for the tuner here on this diagram. There's another little interesting observation here. I'm looking at these outputs on the amplifiers. So we have our main speakers. The top ones are our front, bottom ones are our rear amplifiers. So I'm measuring, I got my switch set at 4-channel here, and I'm measuring the voltage output. I got like 20 some millivolts there, 50 millivolts there roughly, and another 22. That one's jumping around a lot. I don't know what's wrong with that channel. And 24 volts here. But when I switch it to stereo, the voltage on the rear amplifiers goes to 0 and disappears, and the voltage on the front amplifiers seems to get larger. If I turn this down, I got 21. If I turn it to stereo, it almost doubles to 41. Same with the other channel. So I'm wondering if this little switch down here puts this into a bridge mode and gives double the output power. That's what I'm thinking they're doing here with this switch. 62 millivolts in stereo, and I turn it to quad, it goes down to 48. So I have a feeling this switch sets up the amplifiers for in bridging mode, and that would explain underneath these amplifiers there's a little PC board with some transistors on it, and they call it an inverter board, and I think that board probably flips the phase for one of the amplifiers so that they work opposite each other, and then you get your bridge effect. But yeah, it's kind of interesting. Alright, so what I've done is I removed the power supply feeds for these 4 amplifiers, these red and blue wires here. They all come from the filter caps, and the other wires are signal and grounds. So let's turn this thing back on, and we'll see what this thing consumes. It's slowly climbing up again. It shouldn't be climbing up. I don't understand why it would be. Unless the main filter caps are drawing power. But where I measured before 26.3 watts, we're already at 22 watts, 22.8, 22.9. So those power amplifiers are only consuming 3 watts between all 4 of them. I find that hard to believe. I have a feeling these filter caps are really old, and they're probably internally leaky. That's probably why we have a high reading here. But I wanted to do one more thing. What mode are we in right now? We're on tuner mode, okay. So as I switch through and take it out of tuner, let's see what phono is. I'm going to write these down. Phono's 13.5. And this is stereo FM. .23 FM mono. It's the same. This one here is, what is this one? Can't read the knob. Discrete FM. FM tuner's still on. This one's just auxiliary. with no other. And the last one is AM. Now I'm going to compare before and afters once I finish recapping. I'm curious as to if these numbers will change. We took the power amplifier out of the equation. Didn't seem to make any difference. Doesn't seem to be the amplifier was running cold to the touch. Couldn't feel any heat. So I don't think those were biased properly. So on with the recapping. Yay. So the first board I'm going after is this little inverter board. It's just hanging out here underneath the power amplifiers. And all this has is it's 2 channels. It's got a little single transistor, and all it does is it flips the signal, inverts it, gives it 180 degree phase shift. And there's 6 capacitors. They're all 47 microfarad at 35 volts. They're all going to get replaced for audio grade because they are all in the signal path. Next up is the preamp board. That's what they call the preamp board here. It has 4 discrete preamp channels. 1, 2, 3, 4. And then on this board on the right hand side it has the 2 phono preamplifiers. And it's got 24 capacitors on here. You get a good look at that. It's pretty filthy with the rosin flux. The interesting thing about this board is all of these capacitors are in the signal path, and there are no power supply decoupling capacitors on this board. And I think I'm going to change that because I was looking at the circuit. There's no power supply decoupling anywhere in this circuit. You got the phono preamp down here, and then you have your 4 tone amplifiers here for the tone board and preamplifier. But they do have holes drilled in a couple spots here, and that will allow me to add a couple capacitors that will bridge the VCC and ground. Here and here, here and here, and they're on the phono preamplifiers, but indirectly they're connected to all these. So if I populate those 4 holes with, let's say this is supplied with 30 volts. I never did check the power supply. 35. So put a 35 volt cap in here, maybe a 220 microfarad, and that will help keep the noise off the power line. And there's really no way to add a capacitor to each of these 4 amplifiers. I probably could tack one on here somewhere. I'm thinking down here there's some pads. It's a double-sided board, interestingly enough, and they have feed-throughs that are soldered with a little piece of wire, because this doesn't have the technology of plated through holes. Looks like here they have some rivets. Maybe it's a rivet. Not sure. But if I can add a capacitor on each one of these to bypass the power supply to ground, that'll do a lot to keep the noise off of these 4 amplifiers, and then addition of these 2 caps will help with the phono amp. So I'll get on that. There's a lot of 24 caps on this. Wow. These are tin plated, it looks like to me, and they'll need a clean before that goes back in. Alright, so here we go. Everything's recapped. I added those 2 220 microfarad caps in the power rails for the phono amp. I still haven't decided what to do here. Looks like they're feeding each little amplifier with a separate power and ground, because that's what's going back to these pins here, these card edge fingers. And there's really no way to, unless I tack it along the back. It looks pretty hokey if I do that. I was thinking this here is a power feed, this line here, and this line here beside it is a ground. I could just tack in a chip capacitor. I could tack one here, here, and here, but that's 3 capacitors, and that leaves this one without one. Alright, so actually it would leave this one without one. I would have to figure out a solution for this one, because the ground is here and the positive is here. I could probably do that. Oh, I'll just leave it alone for now, and I'll think about it and then come back to it. Next up is the SQ board. This board handles matrix decoding or doing something. I don't think it does full matrix. They have a schematic of it here. And yeah, it's loaded with capacitors. It's got all these styrene capacitors too. I'm going to check a lot of these. These are styrenes are fairly stable, highly stable, and accurate too. They don't drift. They don't change with temperature. But I don't think they're immune from moisture or anything like that. So again, I'm going to recap all these. I think 35 I counted on here. I'm not sure. And I don't know what I'm going to... I might have to do something with these potentiometers, these trim pots. So I'll get started on that and get this board done. I'm looking this over here and I'm seeing the same thing again. I'm seeing lots of electrolytics in the signal path. Wherever you look, you have electrolytics on both sides of the transistor, both sides of the transistor here, on the input of these transistors. And I'm not seeing any power supply bypass capacitors. Here's the supply for this board, B5, and it goes up, splits off here, it goes to resistors, keep following it, resistor, resistor, resistor. There is no capacitor on this line, and there should be a capacitor, blah, blah, blah. There should be a capacitor on board to bypass any noise that comes from anything, you know. Same with this one up here, the other channel. This is the left channel up top here, and there's no capacitors on the power feeds. So I'm going to add some. I don't know where I'm going to put them. I'm going to have to figure out a location for something. I'm assuming this is here is ground, so that would make it easy. But I don't know where the power feed comes from. I have to look at the schematic and figure this out. Yeah, these are all signal caps, so they're going to be all audio grade. Alright, so the SQ board's finished. Cleaned it up. I added a couple of capacitors. I don't know if you can spot them. There's a 22 microfarad capacitor here and a 22 microfarad capacitor here. They measured out 16 or 17 microfarad, but they're 35 volts chip capacitors, and these are, I just tacked them on the end of this line, end of that line, and then I tacked in a couple of these black and green, red wires here. They're just jumpering the power across these lines, and I just snuck a 100 microfarad cap in beside those leads. So this is going to be a lot better now. It's going to be expected. It's going to be quiet. It was fine before, but it's going to be better now. This one here, we have two 220s up top, and I didn't do anything with these ones. I could go underneath the chassis and tack them on to the power feeds that are on the connector. Haven't decided yet. Or I could just leave them alone because it worked fine with it, like the way it was. Okay, here's the 4 power amplifiers, and just remove them. I'm going to service these next. Like I said, somebody replaced these 2 transistors because they are not the same as the others. And a lot of these transistors are actually loose. If I snug them down even further, the screws are not very tight. I guess that works over time, they work out. Flipping them over. These ones look untouched. This one looks untouched, but somebody put red paint on these screws. I don't understand what they were doing here. They were trying to lock those screws in. Doesn't look like the board's been worked on. And it looks like it has all the original parts. So this one here had some carnage. Emitter resistor blew up. It's just scorched back here. And this wire is burnt, probably from the emitter resistor. 2 transistors were replaced. these driver transistors have been replaced as well, and this is a National Semiconductor MPSA06. If that's what they're using for the driver, I don't think that's right. Somebody subbed these in. And what is this one? This one's probably the PMP complement. I can't read it from this angle. To get a better light. Oh, here we go. No, I still can't read it. Anyways, I'm thinking of replacing those two drivers. Put something a little more robust in. Pads lifted and damaged. These pads are very fragile. You got to make sure you don't overheat them. You don't put any stress on them when the iron's on, otherwise the pad will just come off the board right away. Okay, so I'm going to clean these up. They're all going to get fully recapped. This one here, I think I might change a couple transistors just to put a beefier driver in there. I don't think that's good enough. These ones have metal can. This one's a 2SC 959. Okay. And then this one here is the complement 2SA 606. And that's the original equipment, but these ones might be a little bit too light. Okay, so I'll get started on this, crack these open. Yeah, they were all loose. Anyways, I'm going to be removing these anyway, so I'll get started on this. Cleanup on aisle 4. Actually, it's cleanup on amplifier number 4. So this is the amplifier that had some carnage happen here. I was looking at this. You got these little transistors here, these MPSA06 and then the MPSA56. It's a complementary pair. These are not rated as well as the originals. They have a lower current rating and lower power rating. Now, whoever did this replacement just looked for a quick fix, I think. And they didn't really research their substitutes very good. They work, yes. The amplifier is working right now, but I don't think this amplifier would survive too long under full power because I don't think these little transistors would handle it. Now, look at this one here. I'll show you this. Right in the middle here is a 2SC380. Somebody substituted this transistor, and this here is a transistor that is intended for RF circuits. You'll find this transistor in FM tuners, in the front end, in the oscillator and mixer and IF stages. This is a little small signal transistor. It's low power. It's not intended to be in an amplifier at all. The ratings for this transistor are not they're not acceptable for what we're doing here. So I'm going to remove that. That used to be originally a 2SC 815. I'm going to put the original back in. And for the two drivers, I'm going to go with a complementary pair of these. This is a 2SC 2690A and a 2SA 1220A. It's a matched pair, or not matched, but they're complementary pair. These are great for driver transistors, and they're more than adequate, and they're robust, and a lot better than these two little piss ants there. So I'll get these three transistors changed out. And I was looking at the damage here. The emitter resistor pretty much went up in flames. It scorched the wiring. It scorched the board really bad. It caused bubbling and heat throughout the board. Thankfully, that's pretty much it. These two transistors also got cooked. You can see how the area is burnt around them. And that's not from a long, slow soak of heat. That's from an instant event because the heat didn't go all the way through. You can see the board in the back is pretty much unchanged. But yeah, it got scorched. We lost a resistor here as well. Somebody replaced this resistor. It's supposed to be half watt, but it looks like they put it in a quarter watt. Doesn't really matter. It's not gonna. A diode here. I think that diode's okay. And the ceramic disc capacitor has got a little black mark on it. Everything else is okay. The 0.27 ohm resistor has been replaced. And they did get it going back up and running again, but I don't trust these 3 transistors to survive the torture test of full power that I'm going to be giving this thing later. So I'll change those 3. Okay, a little tip for the new players that are here. Make sure you double and triple check your transistors, because I actually replaced this transistor and put it in backwards. It's my bad eyes. I couldn't see the lettering on the one side, so I put it in backwards, and then I assumed it was in right, and then when I put this one in, I looked and it was opposite, so I double checked, and yeah, it was in backwards. I made that mistake. And then this one here, even though it is the same part number as what's supposed to be in here, this transistor has a different pinout from the original, so I had to do a little leg switching here to get it to fit into the place. Now this is unusual. Usually you have a transistor with a part number, the leads should all be the same, it should match, but in this case it didn't. Different manufacturer. So pay attention to that and double check, triple check. I want to show you something interesting here. Just checking out the main filter capacitors, and I'm checking them in circuit. And yes, I can check them in circuit because I've removed all 4 power amplifiers, and these are essentially isolated from everything. We have a diode bridge here with the blue wire. The blue wire goes up to the power amplifier, other blue wire goes to the other power. So they're all isolated. And these are, let's see, what are these again? 6800 microfarad at 35 volts. These are Nichicons, good quality capacitors, but date codes 1973. So we're approaching 50 years old on these capacitors. And I just want to show you a thing. I don't know if you can see. I'll put you up on the meter. Okay, let's have a look at these capacitors. Here's the first one. Okay, there's the first one, and it's reading around 8,000 microfarads. And you're probably thinking, oh, that's a good capacitor. Well, no, it isn't. ESR is good. Capacitance has gone up. The reason it's gone up is because it's leaking internally. And if I go to DC resistance, we'll see what that leakage is. It's around 50 ohms, 70 ohms, 75 ohms. So that capacitor has a 75 ohm resistance now. Let's go back to this, and we'll check the other ones. Here's the next one. This one's measuring 7,700. Nope. 8,000 DC resistance. Again, it's unacceptable. Let's see here. Third one. Let's go through and connect this one up here. This one has a DC resistance of 65 ohms. 72. It's got a capacitance of around 8,100 microfarads, which is a false high reading because the internal leakage of the capacitor will fool the meter into thinking it's a bigger capacitor than what it actually is. It measures bigger than what it is. That's what I'm trying to say. Okay. Last DC resistance. They're all about the same. So yeah, those capacitors are done. They're 50 years old. So, and here's the other. Let me check here. Short this one out. Let me test this one. And there's a 2200 capacitor here. It's 2 inside this one can. Let's measure this one. This one has internal leak. This won't be accurate because this one's still in circuit. So let's go here. And it's reading, it's been at 2200, it's reading 2700. Other side, about the same. So yeah, I'm going to replace all these capacitors because they're done. So if you're going to recap the tuner, and yeah, I suggest you do recap the tuner if the caps in this are all the same, and they're going to be bad too. You're going to have to remove this little can cover here, a little cover there that covers this circuitry, and there's 4 more hiding here. These are 10 microfarad at 16 volts. These can be just regular grade caps. They don't need to be audio. I think it has something to do with the automatic gain control or the AFC or something. I don't know. I didn't look at it too carefully, but there is 4 caps here that need to be changed. All these other ones are pretty straightforward. There are a bunch of 10 microfarad caps in the audio path, and those I put audio grade, and for the rest of them I just use regular caps because they're like power supply bypassed and everything's good that way. So I'm just about done here. I got to change these 4, and then that's the last 4 to go in. Other than that, everything else is done, except you can see I got the new power supply caps in. That was a job and a half. Took me all day. I'll tell you, it was not a fun game because you have to get in here and rewire everything. For this cap here, this is the power supply for tuner and preamplifiers and whatnot. So there's 200 or 2200 microfarad caps in here, and they are both dead or dying. So I replaced those underneath here, and I left the can in place. I didn't want to remove the can. I just want to leave it so it, it looks better. And then these 4 got changed. So yeah, everything's looking good. I'm just about done. And then after I've changed those few caps, it's on to cleaning knobs and switches. And I need to deal with this balance control. We'll get to that soon. So I think I figured out why this thing was so heavy. I took the face off. This thing is like a boat anchor. It's, what is this, die-cast zinc or something? It weighs about 5 pounds. But anyways, I'm going to cut this video off here. I got a lot of work done. I got all the capacitors changed. Pretty much repaired that one amplifier. I still have more to do. I got lamping to do. I got to fix the joystick. I still have a lot of things to do. I want to go through and do a complete alignment on the tuners, and then I set up the amplifiers and all that. So it's going to take a long time. And today's Wednesday. I've been working on this for 4 days now, and I want to get this uploaded so that you guys have start getting back to regular weekly episodes here. So I think I'm just going to stop this here and edit what I got right now and just post it up, and then we'll come back to this again. But yeah, this is a lot of work. A lot of work for this one. Look at the bag of capacitors. And they're all bad. Every one of them is bad. Like they're all, well, actually that's not true. There's a couple of good ones in here. There's some that have completely failed, and then the rest of them are all like 20-30% over in value, out of tolerance. And yeah, so I'm gonna leave it there. All right, thanks for watching. Take care. We'll see you on the next one.